Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone and welcome back to the second part of natural language processing in the continuation series of machine learning with scikit-learn. So we are trying to see the implementation of the sentiments provided for a food review, representing the negative ones with 0 and the positives with 1. So we have imported the necessary libraries and the data, followed by looking about two major expressions or the libraries, that is the regular expressions and NLTK library. So we are importing regular expressions, which gives us a specific parser that we want to pursue in a specific given string. Now we'll be looking at the implementation in the coming. After that, we call a very specific library of NLTK, which is Natural Language Toolkit in Python, as one of the implementation libraries of natural language processing. Inside that, first thing we do is to download the stop words. Now stop words are simply the words which does not hold any information value to the given sentence. For example, a, the, is, are, like that. So we need to remove the stop words which is present inside the one, as since they will be not giving any of the information about the sentence or the sentiment to the same. Once that is done, we call the stop words from the corpus and the porter system. We'll be looking at that. Now the corpus simply means a structure of strings or the natural language data through which we'll be working on the same. Now since we have 1,000 values in our data, we'll be running the for loop for 0 to 1,000, followed by, in the regular expression, we only want to take the string or the alphabetic characters. Now for example, in this one, if I have something known as $1199, which is not actually an information for me, so what we do is that we only take the sentence part which happens and only taking that into the consideration. So that is the regular expressions doing this for us in the data frame of review. So as you can see, the stop words have been downloaded and up to date. And after that, once that is done, all we have to do is to classify all of the text or the strings available into the lower class, splitting that up and doing the porter stemma, which is the normalization in natural language processing. Now what we do is that we only take the sentence which are in English for the data pre-processing word and take the stop words and remove them out of the corpus that we have made of a list. Once that is done, we join back each of the string. Now the string is passed. It is now only having the only information, followed by all of them in lower cases and with no stop words. Once that is done, we append that into the list again of the corpus. So let's implement that. As you can see, it's implemented. Now let's move forward for conversion of string into vectors, and that is done through count vectorizer, and which is available in scikit-learn feature extraction of text. What that does is each string is converted into a vector and giving a maximum number of feature to the one, we say that this is the complete distribution or different types of vector that you have to make and to grab insight only out of that same. So once that is done, we call the count vectorizer and pass the maximum number of features that we want to provide. Now since there are 1,000 entries in the same, we say only different information words as maximum of 1500, not more than that. Once that is done, we call it in an instance and fit the values of the corpus list that we have made inside the value of x, followed by the reviews which is provided in the data frame in the values of y. As you can probably guess from the same, it is supervised learning since we are having the targeted x and y values. Once that is done, we do the train test split again, converting the test size to be 20% and the training set to be 80% and having a random state of 0. So once that is done, now we are using a naive based classifier in this one. Our naive based classifier implements the classification based on the naive based network, which becomes one of the most implemented function in the classification library. And in this one, we are specifically calling something known as the Gaussian naive Bayes algorithm. So inside naive Bayes subclass, we call the Gaussian naive Bayes and make an instance out of it. Once that is done, we fit the value of x train and y train in the same and run. Now Gaussian naive Bayes takes the understanding of classification of the network from the previous value provided and learns from the same. Now what the best thing about the Gaussian of the naive Bayes classification is that it understands and learns of each time or each implementation, which allows it to grow better and better over a period of time. So once that is done, now the classifier has fitted our model and trained the data. Now all we have to do is to predict the values which is given. Now since the 4 variables were provided of x train, x test, y train and y test, now we can put the values of y predicted in the y predicted value. So as you can see, these are the y predicted values we have, and if we look into it, we have the y test values too. So if we compare to both of them, these are the labels which are predicted as the positive or the negative reviews provided for the hotel or the food, and these are the original values which were provided as a review by the customer. So we have to look into the how much the scikit-learn is able to understand the classification of emotions in the same. To do that, we simply use the matrices library and call the confusion matrix. The confusion matrix gives us the classification of the correct predicted value versus the wrongly predicted values. As you can see, we have a high distribution of numbers in all 4 of them. So let's see how much accuracy we have obtained from the method that we have provided. To do directly the accuracy, we call the accuracy score function from the matrices, and let's look at the accuracy that we have obtained. So it's given the accuracy we have obtained is 0.73, representing 73% of accuracy on the y test versus the y predicted values, which is a pretty good score as compared to the size of the data which is provided. And that is one of the sentiment analysis or the implementation of natural language processing in scikit-learn. So we'll be looking at the other class. Till that, take care.